So problem number 41 is one of those scenarios here where we're going to have to use u twice. Once for the pair of negative theta, and then the derivative of negative theta is going to be negative 1. And then for this one, we're going to take u to be the cosine of cosine times theta, and then the derivative of that is just going to be theta. So we're going to be careful on when we plug it in, when we don't plug it in, and there are times when we don't have to plug it in. Like for this right here, this never changes, so we're not going to put in the whole u and du thing for that. However, we are going to replace for this because of the fact that it's going to be involved in the derivation process. Plus, this does get involved in the derivation process over here, and that's when we will use the u's and the du's. So the power rule, the chain rule can be done at our discretion as long as we distinguish between the two sets of u and du. And so that's why I use the blue color for the transcendental part of it. And, well, actually they're both transcendental, I guess. And these are, the green is going to involve the base of 2 when it's being derived, not using when it's not being derived. So that's the difference between the two. So this is a problem right here, 2 to the negative theta times cosine delta theta. We're going to derive that. And so this, we're going to take this times the derivative of the cosine pi theta. And we're going to replace pi theta with u, and then of course that would be times du. And the derivative of cosine is negative sign, so that's why we have that. And we come over here. Now we're going to take this and multiply this by the derivative of 2 to the negative pi, or negative theta rather. And so this is where we're going to replace the negative delta with u and the du. I actually did not need to put that there as a separate entity, so because I'm not deriving that, so that was not necessary. I just kind of did it for emphasis to show that that can be done. But as you can see in the next step, I just put it right back in like nothing ever happened. So for this one right here, once I derived this, got the derivation from here to here, then I went ahead and plugged this stuff back in. Now, you have to be careful again that this is the sign of a value times a separate value. So that means we're going to put that pi in front of sine theta pi here. And this stays right here as part of this term of this two-part expression here. 2 to the negative pi, or negative theta, is moved in front here. And because of the negative 1 here, that changes the addition to subtraction. And it gives me cosine theta pi times the natural log of 2, based upon the derivation we had when we went from here to here. Now this is where the mathematical manipulation comes into play. We factor out anything that we have in each term. And so this will be 2, we have a negative 2 to the negative theta in each term right here. We have nothing else in common, so we just pull that out. And this should have a last pair of parentheses because the negative 2 to the negative theta is going to multiply that whole thing out right there. And that is your answer for number 41. Number 43, we're trying to find the derivative of the function log base 2 of x squared over x minus 1. And this is another one of those scenarios where we're going to have two different parts of the power rule thrown in there just to make life a lot easier for us. Do you have to do this? My feeling is no, you don't. But it just makes life a lot simpler to get rid of all the extraneous exponents and subtractions and all that, and just put in a single u, and then you can plug it back in, and then the complications occur from there. Save yourself a little bit of grief by using the u as much as you can, but you don't have to do that. Just that when you bring bring your assignment to me and I have it on my card, I'm going to have to sit there. It probably takes me a while longer to grade it to figure out exactly what you've done where. But that's my problem, not yours, except for your lack of patience. Then it is your problem. Anyway, so I'm using the green and the blue U values there. And so the first thing we did here was we rewrote this as a subtraction between the two exponents. Remember, logarithm means exponent and the base is 2. So if you're taking the logarithm of x squared over x minus 1, then you're taking the exponent of 2 to the x squared minus the exponent of 2 to the x minus 1. So those exponents are being subtracted. That's what log means. So we subtract the exponents, which again makes life a whole lot easier. Why? Because now we can start plugging in our u to u's in both cases. For this one right here, we're going to get rid of the x squared and make that u, and then that means the derivative of that becomes 2x. Derivative of x minus 1, the u is going to be x minus 1. Derivative of that is just plain 1. And you see, it just kind of cleans things up a bit. So, according to theorem 513, if we take log base 2u and derive it, we get 1 over the natural log of 2 times u du dx. And the same thing over here, 1 over the natural log of 2u du dx. So, same thing, except our u's are different colors, meaning different values. So once we got that established, we go ahead and plug in this stuff right here. And this indeed is what's going to happen here. U gets replaced with x squared again. And the du dx becomes 2x. And over here, the value of u is x minus 1. And that's going to be times 1 because that's the value of du dx. And now it's just a matter of playing with mathematical concepts here. So I'm going to put the 2x on top, and when that happens, an x cancels out with one of the x's here to leave us x natural log 2 on the bottom, and just plain 2 on top. Over here, this just becomes minus 1 over x minus 1 natural log of 2. Does it make any difference what order you put in? No, not really. I just prefer that. You put the x's on the front and the natural log garbage on the back side of it. Now, at this point, we are going to find the lowest common denominator because we want to make one fraction out of this. The lowest common denominator is x times x minus 1, and they both have a natural log of 2, so we'll just have one natural log of 2 in the denominator. So x natural log of 2, x natural log of 2 cancels out, leaving x minus 1. So we're going to take x minus 1 and multiply it by 2. In the other fraction, x minus 1 natural log of 2 cancel out, leaving x, and x times 1 is being subtracted here. So we just go ahead and clean it up. Distribute the 2x minus 2, and then minus x times 1 is minus x, and 2x minus x is x minus 2 over that denominator, and that's our answer. Number 45. This is log base 5 of the square root of x squared minus 1. So what we're going to do is that we're going to first of all, if we derive this, I'm going to replace the u right here, u for x squared minus 1. So when that happens, then this becomes 1/2 1 over natural log of 5 times u, and that's du dx. Okay, so then I plug that back in, and like I said, since du dx is 2x, that's going to go on the outside. Substitute the x squared minus 1 back in right here, and the 2 and the 2 here cancel out, and it leaves us x over natural log of 5 times x squared minus 1. Not too bad of a problem. Okay? Alright, so those are our examples of what you'll need to do here. Your practice problems then are going to be 38 to 46 even. Have fun!